fellow ticklers. My talk will be about AndroWish meets the ingeniously delightful Internet of Things. And you see rosy prospects. That's not a blue cloud, it's a rosy cloud. Okay, my talk is about Bluetooth 4.0, which is also known as Bluetooth Smart or Bluetooth Low Energy, or for short BLE, which is supported on Android devices starting with version 4.3. If your Android device has Bluetooth built in and you happen to have a 4.3 or 4.4 or even 5.0, then you will get Bluetooth Low Energy support for free. And this is used in the Internet of Things to, for example, to deal with sensors or to deal with actors. It is made to have very low energy requirements from the point of view of the sensor of the actor. It's made to be fast in the connection setup procedure, and it builds on the so-called generic attribute profile, which is part of the Bluetooth 4.0 standard. This general attribute profile has some entities. It starts by a service, which is let's say a collection of characteristics. Characteristics are measured values, for example. And those are described by the so-called descriptors, which describe a measured value, let's say, by its access, by its readability or writability, or if it's able to send out notifications or events. It also has some means to detect both Bluetooth Low Energy devices plus all their built-in services, characteristics and descriptors. So if you do a device discovery, you can find out which services and other stuff is on this device by using the generic attribute profile. Think of automatic setup to an unknown device in theory. All kinds of objects, services, characteristics, descriptors are in the GATT described by very handy 128-bit UUIDs. You see here some. And this is a predefined descriptor which is used on a characteristic if the characteristic has some kind of notification to disable it or to enable the notification. Because the UUIDs in the long form are very unhandy, there are rules to abbreviate them. So basically you write the second 60-bit value or the first 32-bit value if this is unique regarding the device. The Android system, starting with version 4.3, has a lot of classes in its framework to deal with Bluetooth Low Energy connections and devices. And you find here in the Bluetooth GATT class some subclasses which reflect the entities which describe the entire sensor. Services, characteristics, descriptors. In order to handle some events, for example, a connection has been set up or has been released, or a sensor value has changed, there's a common Bluetooth GAP callback interface which you have to implement in your application, which gets certain kinds of events, for example, like when the sensor value has changed, or when you have written a descriptor or something like this. So my part was to have this transformed into the TcL world with very longish stuff in the TcL world, and you see here the plan, the blueprint. We have here the Java side, and we have here TcL. This is C code, and here we are on the script level. So I have some Java glue code which calls out into the Android Bluetooth.star classes, which implements the callbacks. For example, a new connection has been established, or for example, some value has been written, or I call from the C side some methods which write out a descriptor value in order to enable a notification or to change a sensor value, a sensor configuration value. And on the C side I have some notion of Bluetooth low energy client, which is basically a table of UUIDs. Information about the callback in the TcL script level. I have per TcL thread one thread-specific data block where a queue is maintained of events coming from the Java side, which is protected by a mutex and which has a pipe in order to wake up a file handler which translates the queue elements into the TcL callbacks. That's the technique. Too complicated?
Yeah, I understand, but I'm afraid
Okay, now maybe this is a little more less technical. In general, the Bluetooth low energy stuff in Android is very, very event driven and asynchronous. That fits the TcL well, I think. I've implemented in the Java part a logic which automatically tries to find out all necessary object dictionary stuff from the remote device during the connection setup. I call it the discovery phase. That takes place automatically if you connect from TcL to a Bluetooth low energy device. And I simplified, I hope, the callback stuff from Java, which consists of, let's say, you have to implement 10 methods or so for writing a descriptor or reading a descriptor. I simplified this into one callback which gets two arguments. One is the event, for example, scan for device scanning, or connection for connection level events, or characteristic for characteristic events, and all the event data is contained in one dictionary which depends from its contents on the type of event. So for example, if you programmatically want to read out a sensor, you start a read operation which goes through the C level into read something here and goes out to the device, but the result is reported back in the callback of the read operation. And in case of a write operation, it's very similar. You get the end of the write indicated by a callback. So the next slide has an overview over the Bluetooth low energy minor commands. You find here things like there are write transactions, which means you can batch a number of writes and commit them just like a database would do. There are close connect to start a connection to a device or to close it. Disconnect, reconnect to start notifications or to disable notifications. Descriptors, characteristics, device scanning, callback handling, find out the signal strength of the remote device, some introspection stuff like give me a list of all services which were discovered during the discovery phase or operations on UUIDs. So the price, man page is here. The price of this interface is about 12 kilobytes Java bytecode measured at compile time, which gets compressed when you deploy it. The native code is for ARM, 12 kilobytes machine code, uncompressed, and if you are targeting Intel 2, another 21 kilobytes. So it's rather cheap if you know that the entire AndroWish already has 26 megabytes. Questions? Okay. So now for the interesting part.
Now you're going to shine the light on that.
Yeah, this one. I hope it works. So we have to distangle it. Mind the color. Mind the color. This is a LED bulb. You read it already and just makes light. So let's make some light. I show you the app first, if it works. Hopefully. It should scan now. It's green, so we are connected. You want disco? But it's disconnected instead of disco. So let's scan again. Something is jamming the Bluetooth connection.
You need a plastic guy.
Where's the disco? Disconnect. Off. Okay.
Maybe the projection is also a wireless connection. Maybe that has to do with it. Have you tried that before?
This is WLAN and that's Bluetooth.
Okay.
Should work.
Yeah, you never know.
Yes.
Probably controlling something else in the building.
If not. Das ist Plastik. Alles Plastik. It connects, but it doesn't control. Okay, maybe it needs some 5 minutes to warm up. So let's go on with my talk. This is the scanning. This is the procedure of scanning, for example. It's done in the callback. You get the event type, which is scan. You get the dictionary with information about it. And in theory, this bulb is detectable by the name iSmartLight something else. And if we detect it, we can connect it by using the Bluetooth address, which is also part of the data dictionary. And because, as you saw, connection is a very difficult process, and it does not always work. I start here with a callback, which I called connection step 1, and close the scanner handle. The scanner detected this device, and BLE Connect creates a new handle which gets the connect step 1 callback, which deals with the connection phase. And in order to get the BLE scanning, I do this command. So, this is connect step number 1, where we have some magic. You see here, if the event type is connection, and we have the state connected reached, which means we are finished with the discovery phase, we have to do some really undocumented magic in order to keep the connection alive. Maybe this is the problem we saw with the device. This is, in this example, wrapped into a transaction which starts with BLE begin, does 2 write operations, and executes this transaction. You see, we have to deal with binary data here, because everything on these devices are small binary objects normally. And then we go on with connect step 2. In the connect step 2, we initially read from service FFF0, instance of the service number null. We read the characteristics FFF1, which is the value of the bulb in terms of is it on and which color has it. And we will see in the next step how the data which is gathered by that read is kept in the BLE user data. The else case deals with connection breakdown and tries to restart device detection and tries then to reconnect the bulb. When you are in the connected phase and the characteristic value is FFF1, we store the value written back, read back from the device into the user handle, into the user data of our BLE handle. This deals with connection down during connection phase. So, and this is the code which turns the bulb on or turns it off. There we write some value which is turn it on, color for cyan, magenta, yellow and white, and this is the value to turn the bulb off. So let's try it again.
How come it's CMYK and not RGB? That's fine. Because it's a lamp.
I didn't create this lamp. They have not the RGB color model. Let's try it again. Maybe this time. No.
Can you set the lamp to broadcast the address? Because I also can't see the lamp on my Bluetooth Discovery.
Did you connect to it?
No, I know. I'm just scanning.
Yeah.
And I can't see, it doesn't broadcast the lamp. So maybe you can somehow...
Do you have Android 4.3 or later?
I have a MacBook.
Ah, sorry. But if it gets green, it should be connected.
Ich muss noch den Netzstecker drehen und dann geht's da so.
Could be.
Das hat man so eine Augen, das stimmt aber auch.
But just a try of the wireless LAN, maybe it interferes.
You're right. I turn off the Bluetooth.
Hey, for Bluetooth you must disable Wi-Fi.
No.
No, not always. No.
But I try to disable Bluetooth and re-enable it again. Maybe this helps.
That's not a stupid idea.
I see the bulb now.
You see it?
Yeah.
Cool. It won't.
So you're
Maybe the bulb can't handle so many connections. We always try to connect to it.
You are not connected. I hope.
So
Once more.
What is it called? iSmart.
iSmart Light.
I can see this. This Bluetooth device. iSmart Line Bluetooth.
I see Apfelkiste.
I see iSmart Line whatever.
Okay. We'll try it later. Let's go on.
Shall I?
You see, I should not work with those old devices. I should do something really new. Let's build a tricorder. I have here a Texas Instruments SensorTech. It's a device, costs about 35 euro at Farnell or some electronic dealer of your choice. And it has built in a small PCB with one microcontroller, which has tons of sensors. For example, infrared temperature sensor, accelerometer, humidity sensor, and so on. And this connects using Bluetooth Low Energy too. So here is a short list of the contained sensors. Each have a measured value. You see here the format, which has to be translated into physical units for most of the sensor values. It has a configuration characteristic in order to turn the sensor on or off, or to even control its update rate. And it has two push buttons, which have, by the way, a standardized UUID. Here are only short forms shown, but if you look in the data sheet, you will see that all those sensor IDs have a base UUID, which is vendor specific, but the buttons are somewhat standardized. So here are two code snippets which show what happens during device discovery. During device discovery, the same information as during normal connection mode is shown in the event callback for characteristics and descriptors. And when we are in the discovery phase and have a property bit set which indicates that this characteristic is useful to send notifications, then this information is collected into a list which is added to the user data of the connection network. And the next snippet shows how to enable all those notifications. Enable the sensors. That's the right word. This is used to enable the notifications, which are GATT property, but the sensors have, as shown in the overview, an extra config characteristic where you have to explicitly turn on the sensor, because some of them are really expensive in terms of battery power. So you can turn them on or off. So that's my tricorder, and here's shown a snippet which shows how the magnetic field sensor is read out and written to a global array. So let's try it. Maybe this time.
Let's see if it turns.
It's scanning. It sees the smart light. Hello. I think you have too much Bluetooth in this room. Can you see this device? It's called Smart Tag, Sensor Tag.
But it is still
Can you see it?
still change. Not yet. I can already see Markut, whatever. Markut. It's a mobile telephone
No.
and
This time I have a chance. Now it's working. And you should see here the sensor values, for example, the temperature. You even can measure the temperature of the bulb because it's an infrared temperature sensor. And you should see that the object temperature of the bulb.
It's illegible, it's still too dark. You can't see the projection.
Maybe I should give you this if we are through. Maybe we try to get the bulb.
What's this little device called, the red one?
Sensor tag.
No, I station, I can't see.
How much is such a thing? Such a little device?
35 euro.
Today, first this is probably the outdated version, the new version now.
Yes.
And if you go to this instrument
I know.
shows, you might get the device for free.
Okay. Yes, because that works, but this bulb is from China, isn't it?
Yeah, okay.
It has a timeout of...
dedicated application?
Pardon?
Do you have a dedicated application for the bulb? It comes
not-
from the vendor that you try with this.
Not on this device. I know there is one, but in theory it should work, but I think here are too much Bluetooth devices. Maybe.
Everybody switch off the Bluetooth.
So turn off all your Bluetooth. Or maybe I changed the code somewhat, but the connection breaks and that's not a good indication. But I'm very happy that the sensor tag works. It disconnects and reconnects and that's not a good sign. Maybe the energy here is too green or something like this. Off. No. Okay, let's try it later.
Is there a certain reason why these bulbs use Bluetooth low energy? They are connected to the main, so they don't actually have to rely on very low energy.
I think the reason is the price, because this bulb costs 35 euros or 40 euros. If you buy a set of three from Philips, which go over a separate connectivity stuff, wireless, then you pay, I think, 300 or so.
No, I mean, they could have used the standard Bluetooth, the traditional
Yes.
Bluetooth 3 for this,
Yeah.
because they don't have a little battery that should last for a year.
Yeah.
So they have made, they can take 100 milliamperes, nobody
Yeah.
would care.
The client device must also be Bluetooth low energy.
Yeah, of course, yeah.
And this one's a battery. So they make
Okay.
one also Bluetooth low energy, even if it has.
Yeah, I think that's a good motivation. Yes.
But the smartphones have the traditional Bluetooth anyway. But,
Yes,
for
but
the-
you-
But think of a remote
take a little
control.
more energy while setting the color. Yes, okay.
Think of a remote control.
Yeah.
Yes, the remote control, not just the smartphone. You have
Yeah.
the remote control. The coin
Yeah.
cell.
They only have a button cell. Yeah, okay.
Well, I think that's all. So thank you. And now for the questions. Harald.
Yeah, we will post this.
Harald.
Did you order through eBay? How did you buy the bulb and the little sensor?
The little sensor is from Reichelt,
Ah.
and I'm unsure if the bulb too, I think. You have to look, the product is Tabu Lumen LT 800 or something like this.
Maybe you can put it into your
Yeah,
things you give to
Yeah.
all so that we have
Yeah.
information what to look for.
I think I have written it in the source code, and the source code is or will soon be online on AndroWish.org. And yes, there is a new kind of sensor tag available, but that was right after, I think, we embedded in Nuremberg, and that was the idea to get one and to try how to connect from tickle to a sensor. So another idea could be to have, only if Linux has, for example, generic Bluetooth low energy support, to make a similar interface on Linux, to have a generic, let's say, Bluetooth low energy support in Tickle would be an idea. maybe.
Just to control with an ordinary PC and not with a mobile device. Do notebooks normally have Bluetooth low energy, Bluetooth 4 nowadays?
I think it depends on the Bluetooth adapter.
If you have an additional one, but not built in.
Depends maybe on the model of the laptop. If it's a modern laptop, it surely has Bluetooth 4.0.
Christian,
Yeah.
in your examples you showed the initiation of a read, for example.
Yeah.
And after that you set the callback. So I assume this is strictly single-threaded code, because if the callback could happen before the read callback could happen before you set it, this would not work.
You mean in
The upper
this one?
branch, with the BLE read handle, and then we set the callback for the
Yes.
for the read.
And this connection step 2 is a transitional thing, which is, you should see here. How is it made? Just think over it.
Yeah, you say execute.
Which carries out the write, the both write transactions. Yeah. And I set the connect step 2 as the next step of my little state machine.
That is the last instructions.
And now the fine point is the event is not something else, but it's the end of the transaction. That means the write transaction has ended, and by this event, which happens only once, this code is evaluated, which reads initially only once the F0 characteristic, and then switches the state machine to the connected state.
But still you would have a race condition.
Where?
No, that's what you mean.
Where?
No, because the
You should
callback
Where?
registers the function.
Where's the race?
I understand it this way. You initiate the read.
Wait. Wait.
On the right.
Here.
Right, yeah.
I start with a transaction. The transaction ends with an event of transaction. Event type transaction.
My question is, while you're in this code,
Yeah.
while you're in the BLE execute, for example,
Yeah.
can it be that while you're in this code, the transaction comes in?
No, because we are we are on one tickle thread here.
Yeah, okay.
And everything you do to the BLE is asynchronous, which means goes to Java, triggers something in the Bluetooth stack. The event is reported back later by
the usual
by the event stuff, exact, by the file handler and the event loop.
Okay. It's just the usual
Yeah.
TCL.
Yeah.
Okay, it's not logic.
Yeah.
You have the pipe which serializes.
Yeah, okay.
The pipe has only one need.
Everything is the same thread.
It's used to have the queue work on a file handler. Which means the pipe is only written when the queue is empty and the first message is put in. Only then one single byte is written into the pipe in order to wake up the event loop. And that's done by a thread outside of the scope of tickle, the write into the pipe. A similar model is used, by the way, in the SDL to XLib emulation to get the TK on the Android. Similar idea to deal with events and to wake up using a readable pipe and a file handler.
5 years ago in Malaysia, we gave a presentation about the SEX protocol. It's a protocol to communicate with machines, lithography machines in Fabric.
Yeah.
That was implemented in full TCL.
Yeah.
But one module we had there was interfaced with the CellWorks library, and that worked exactly the same.
Okay. Fine.
So that's the best way to do it.
Yeah. Okay, so let's try the last try for the bulb. Turn it off. Turn it on. Scan. It's not green, it's red. Now it's green. Now say disco. No disco today. I'm sorry.
Okay.
Okay, thank you.
Maybe you can try later.